Good morning, everyone. Welcome back to day 3 of PGCET crash course conducted by RNSIT in collaboration with 7sense. We are excited to have you all here again. Today's focus is on computer awareness. This is a key topic for PGCET and will help you to boost your overall score. So let's get started. Today we are focusing on computer awareness. First, we are going to start with the basics of computer. Objective: understand the components of a computer system, learn about the type of memory and storage, and explore data representation technique. Second. Now, let's see what is computer. From schooling, you all know this what is computer, right? And you know this definition also. A compute and electronic device that process the data and perform task according to instruction. This is called a computer. And main functions of computer is input, processing, storage, and output. These are the basic things we are learned from the schooling. So what is input here? Input is nothing but the data. Input is a data. And output is a result. These are the main functions of computer. Is my voice is audible to everyone? Yes. Then let's see the components of computer. Hardware, software, and user. See, hardware components means physical parts. So CPU, monitor, keyboard, mouse, scanner, along with scanner, and microphone. These are the hardware parts. So these are CPU, monitor, keyboard, mouse, and scanner. These are the hardware parts. Then what is software? Programs and operating system. These are the software parts. Then user, people who interact with the system. People who interact with the system are called as users. Physical part of a computer means which you can touch. Those are called as physical part. Yeah, input device, keyboard, mouse, scanner, microphone. These are the input device, and your see this scanner is not an input device. Hardware parts, physical parts are CPU, monitor, keyboard, and mouse. And input device are keyboard, mouse, scanner, microphone. Don't get confused. And output devices are called monitor, printer, speaker. These are called as output devices. Okay, what are storage devices along with this? Hard disk, right? Hard disk, SSD, then USB, USB drive, USB drive, CD, DVD. These are storage device. Remember that input device are keyboard, mouse, scanner, microphone. Output device are monitor, printer, speaker. Storage devices are hard disk, SSD, USB device. Sorry, USB drive, then CD and DVD. These are storage device. And we'll recall this also along with that. Hardware, physical parts, CPU, monitor, keyboard, mouse, software, program, and operating system. OT CPU, central processing unit, is called as CPU. This is also called as brain of computer. It performs calculation, ALU, arithmetic logic unit. Control unit means manages operation. Memory type, primary memory. RAM is a volatile, ROM is non-volatile. So, what do you mean by volatile? This means data is lost when power is off. This is called as volatile. So, RAM is a volatile memory. So, what is the full form of RAM? Random access memory. Remember that data is lost when power is off. Okay, full form of ROM, read only memory. Read only memory. This is a non-volatile. This is opposite to volatile. So what does it mean? Data remains even after the power off. That is the difference between volatile and non-volatile. So in RAM, we have static RAM and dynamic RAM. Static and dynamic. SRAM and DRAM. This is dynamic. In a static RAM, this is faster. This is faster. This is faster. And this is slower. Then use it to store cache memory. And this is used to store main memory. Main memory. These are the difference between static and dynamic RAM. And in ROM, we have PROM, E, P, ROM, E, E, P, ROM. So it is programmable once. PROM means programmable once. That's all. EPROM means erasable with UV light. This is erasable with UV light. Then this is electrically erasable. Electrically erasable. I'll repeat it again. In RAM, we have two types. One is static RAM, another one is dynamic RAM. In static RAM is faster, dynamic RAM is slower, and it store a cache memory and this store a main memory. Okay. In ROM, we have PROM, EPROM, EPROM. PROM means programmable read-only memory. This is the full form. Once again. Programmable, P for programmable, R for read, O for only memory. Programmable read-only memory. So next, what is EPROM? Erasable, programmable, read-only memory. Erasable, programmable, same, read-only memory. What is EEPROM? Electrically erasable, programmable, read-only memory. I'll repeat it again. In RAM, we have only two types, static and dynamic. In ROM, we have three types. One is PROM, programmable read-only memory. EP, erasable, programmable read-only memory. And third one is electrically erasable, programmable read-only memory. Got it? Next. These are primary memory. These are primary memory. Now we are looking into secondary memory or secondary storage. We have for secondary storage we have HDD, SDD, CD, DVD. HDD means hard disk drive. It is a magnetic. This is a magnetic storage. Magnetic storage. Remember that HDD is a magnetic storage. It has a large capacity up to TB. But this is slower than SDD. I'll repeat it again. Hard disk drive. HDD means hard disk drive. It is a magnetic storage. It has a large capacity up to TB, slower than SDD. Slower than SDD. Then SDD means solid state drive. Solid state drive. This is a flash based storage. Then it is more faster than HDD and more expensive. This is more expensive than compared to HDD and it is more faster than HDD. CD and DVD are called as optical drives. This is called as optical drives. Next. We are moving into software types. Software, system software, OS, Windows, Linux, Mac OS. These are system software. Application software, MS Office, browser. These are called as application software. And let us learn about utility software means utility software. Antivirus. Antivirus is called as utility software. Or any disk cleaner. This is also utility software. Then programming software means programming software. It is nothing but tools for coding like Python, Java. The tools what we use it to code this are called as programming software. These are types of software. Mainly we focus on system software and application for software. And along with this, can you give any example for OS operating system? Leaving this window, Mac OS and Linux. We have Android. This is the system software. Then, and this is a operating system. Then iOS. These are the exam for system software. Example mainly for OS, operating system. Example for OS, operating system. Windows, Linux, Mac OS, Android, iOS, Linux. These are the operating systems example. Along with this, we'll learn about generation of computer. The history of computer is divided into 5 generations. And first, we'll learn about the first one. It is a vacuum tube. Technology used is vacuum tube. One second. In this, the programming language was machine language. Language, and it was a binary code. What are binary? 0 and 1. For memory, they used magnetic drums. For memory, they have used magnetic drums. For input and output, they have used punch cards or paper tape. They have used punch cards. And in size, it was very large. It was very large. Consumed a lot of power. Required more power to operate. And speed is very slow. Very slow. Example for this is, take the example, this is very much important. ENIAC UNIVAC EDVAC. These are the example for the first generation. Now we'll move on to next one. And limitation for first generation is it is overrated easily, required AC rooms, and it is very costly mainly. And these are the example for first generation. And second generation, instead of vacuum tubes, it was replaced with a transistor. Technology used is transistor. We have replaced vacuum tubes with transistor. And programming language was assembly language. And memory. Previously in first generation, for memory we have used magnetic drums, but here we are using magnetic core memory. Magnetic core memory. And previously in first generation for input and output, we have used the punch card. Here also we are using the punch cards. Punch cards and printer. Previously we used punch cards and paper tape. Here we are using punch card and printer. Size. Smaller than the first generation. Smaller than first generation. Speed. Faster and more reliable. Faster and more reliable. And advantage of this is less heat and cheaper compared to first one. It was cheaper than compared to the first generation. An example for this is IBM 1401, IBM 7094. These are the example for second generation. Take this example. Next. Moving to the third generation. Now, technology used in first generation was vacuum tube. In second generation, we have used the transistor. In third generation, we are going to use ICs. ICs is nothing but integrated circuit. Then programming language was high-level language. We have used high-level language here. Previously, there we have used, in first generation, we have used the machine language, binary 0 and 1. In second generation, we used the assembly language. Here in third generation, they've used high-level language in third generation. Then memory. Here they're going to use the semiconductor memory. So in first generation for memory, they have used magnetic drums. In second generation, they have used magnetic core memory. In third generation, they have used semiconductor. Then size, even more smaller than the previous one, even smaller. Then speed, faster compared to previous one, faster. And this one, advantage, low cost, better performance. And here they have introduced the multi-programming. Low cost, better performance than previous one, and multi-programming are the advantage of this. And example for this is IBM 360, PDP 11. These are the example for third generation. Then to fourth. Fourth generation is of microprocessor. Technology used of microprocessor. Microprocessor are used in this. There is VLSI. Then programming language. High level language. C. Then devices. Programming languages used. Then devices are like PCs, laptop, then mobile phone. And in fourth generation, GUI was introduced. What is GUI? Graphical user interface. Graphical was introduced. An advantage of this is very compact, portable, high processing power. Advantage are very compact, then high processing power, internet and multimedia developed in this. So example for this is Intel, IBM. These are the examples of this. So see, first generation duration was from 1942. 1942. They used this from 1942 to 1956. And second generation was from 1956 to 1963. Third generation, 1964 to 1971. Then fourth generation, 1971 to present. So now let us see about fifth generation. Fifth generation, it is present and beyond. Present to beyond. This is a AI technology. AI technology. Technology used in this is AI, machine learning. Fifth generation is mainly artificial intelligence, that is nothing but AI. Then technology used in this is AI, machine learning, AI, machine learning, quantum computing, quantum computing, then robotics. The main aim of this generation is make computer think and make decision like humans. Languages, programming languages are high level programming language. So in this the futures are like voice recognition, image recognition, cloud computing. These are the few futures of fifth generation. Example AI tools like ChatGPT, Google Assistants, self-driving car. These are the example for fifth generation. The well look into what is data. Data refers to raw fact, figures, or symbol. So the data processed or stored for various purposes. Data can be in different forms such as text. These are called as data will be in raw fact. Okay. Text, for example, hello, word, this is a data. Then numbers 1, 2, 3, 4, 5.6. If it is in decimal also, that is a number. Image, JPEG, and PNG files, audio, MP3, MAV, and video, MP4, AVY. These are the example for data. Data representation in computer. Computer use binary system to represent data. Binary system means it is zeros or ones. All types of data like numbers, character, image, audio, video are converted into binary form for processing and storage. What I showed you in the previous slide, this will be converted in the form of binary and stored. They'll be converted in binary and then they have been processed and then they have stored in form of binary. Digital data is equal to electronic signal, then they're converted to a binary code. Number system. Binary means base 2, 0 and 1. Decimal means base 10, 0 to 9. Octal means base 8, 0 to 7. Hexadecimal means base 60, 0 to 9, then A to F. I'll write for hexadecimal 0, 1, 2, 3, 4. 1 second. 3, 4, 5, 6, 7, 8, and 9. Then they have given A, B, C, D, E, F. Right? Here, after 9, 10 means A. So 11 is B, 12 is C, 13 is D, 14 is E, 15 is F. This is how they have given. First, they have written from 0 to 9. Then for 10, they have taken alphabets from A. From 10 to 15, they have taken alphabets from A to F. Remember this. The value of A is 10 and for F is 15. Remember. Then binary to decimal conversion. What they have done here, this is in a binary form. They have converted this to decimal base 10. To convert from binary to decimal, let us take this example itself. So this is the first position. For that, take this 1. Binary means 2, right? So multiply with 2 and start the power with 0. Plus. Next is what? We have 1. So 1 into 2. 2 because binary means it is 2. So here we have started with 0, then here it has to be 1 plus. What is the next number? 0. So into 2 to the power 0, 1. Here it has to be 2. Again, plus 1 plus 1 into 2 to the power 0, 1, 2 is then for 2 it is 3. Now we have to find the decimal of the given binary digits. So 2 to the power 3 means it is 8. 8 into 1, 8 itself. 0 into anything, it is 0 plus 2 power 1, it is 2 into 1, it is 2 plus 2 power 0, it is 1. 1 into 1, 1. So adding all this, the decimal, when you're converting to decimal, then the value will be 11. 11 base 0. Sorry, base 10. 0, 1. This is your binary to decimal conversion. Next, decimal to binary conversion. So I'll take this as an example. We have to write the given decimal number here and you have to divide by 2 because we are converting to binary, right? 2 6 are 12. So remainder is 1. I'm writing the remainder. Next. 2 3 are 6. 0 is the remainder. Next. We have to divide by 2 itself because we are converting to binary from decimal. So 2 1s are 2. 1 is the remainder. Then 2 1s are. So we won't get, we cannot divide. So it is 0. We cannot divide 1 by 2. So it is 0. And what is the remainder left out? We did not divide this 1. So that we have to take it here. It is 1. Now you have to write the number from below to up. So what is there? At first 1, then 1, 0, 1. Base 2. This is a we convert from decimal to binary. Again, we'll try this. We're converting this 27 decimal number to binary one. So let us write this. 27. We are converting to binary, so I have to divide this by 2. 2 13s are 26. So remainder is 1. Next. 2 6 are 12. So 12 minus 13, 1 is the remainder. Then 2 3s are 6, 0. Remainder 2 3 are 6, so remainder is 0. Then 2 1 is a 2, so remainder is 1. Then 2 zeros. We cannot divide this 1 with 2. So what is the remainder now? 1. So we have to write from downwards. So your answer is 1 1 0 1 1 base 2. This is your answer. So now we have two decimal points. So how will you convert this into binary? Same way. But for this, we are using the different method. For this, we are using, for 10, we are using different method, and for 20.25, different method. First, for 10, we have to divide it by 2. 2, 5s are 10, 0 remainder. 2 2s are 4, 1 remainder. Then 2 1s are 2, 0 remainder. Then 2. We cannot divide 1 by 2. So it is 0 and remainder is 1. So you have to write your answer from downwards. So 1 0 1 0. Answer is for 10 it is 1 0 1 0. Now we need to find the answer for 0.25. This we need to convert to binary. So here it is different that you have to multiply. Here we are dividing by 2, but here we have to multiply this with 2. So 2 into 0.25 is how much? 0.5, right? 0.50. Next. Now this number we need to multiply with 2. So it is 1. Till we remove the decimal points, we have to follow this process. Now we got 1 here, right? So when you're dividing, you have to take the value from downwards. When you are multiplying, you have to take the value from top. You have to take this and this value. What? From top, 0 and 1. 0 and 1. And you have to keep the decimal point. And base 2. We have converted 10.25 base decimal to base 10 to binary 1010.01 base 2. This is how we need to solve. Now, 1 bit is equal to smallest data unit 0 or 1. 8 bit is equal to 1 byte. 1 kilobyte is equal to 1 kilobits is equal to 1024 bytes. 1 MB is equal to 102 KB, 24 KB. This you need to remember. Bit means 0 and 1. Bytes means 8. 1 byte is equal to 8 bits. Kilobytes is equal to 1024 bytes. Megabytes is equal to 1024 KB, kilobytes. Gigabytes is equal to 1024 megabytes. Terabytes is equal to 1024 gigabytes. You have to remember this data unit table. Okay. Before going to practice question, let us solve few more problems related to this. Let us take an example. Let us take the example of 101010. Let us convert this to decimal. Let us convert this to decimal. This is binary to decimal. What we have to do? So these are in this binary now. So when you want to convert to decimal, you have to take this letter, this number, and you have to multiply with 2 because the base is 2, right? Binary is 2. So 2 to the power how much? You have to start with 0 plus. Next, take the next number 1 into 2 to the power 1 plus next number 0, right? 0 into 2 to the power 2 plus next is 1. 1 into 2 to the power 3 plus 1 into, sorry, next is 0. 0 into 2 to the power 4 plus 1 into 2. So let us write these values now. 2 power 5 means that is 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. So 2 power 5 is 32. Into 1 it is 32 itself, plus 0 into anything it is 0, plus 2 power 8 means it is 2 power 3 means it is 8, plus 0 into anything it is 0, plus 2 power 1 it is 2, plus 0 into anything it is 0. Adding all this will get 42. This we have converted binary to decimal. 42 base 10. This is your answer. We'll take one more example. One 0 0 1 1 0 1 1. We'll take a random binary. Okay. So first, let us take first number into place value is 2 to the power. First, we have to start with 0. At last, we'll write the values. Next, 1 into 2 power 1. 0 into power 2 into 2 power 3. Again, 1 into power 4. It is 0 into power 5. 1 second. Okay. Next is 0 into 0 into 2 power 6, and then at last it is 1 into 2 power 7. Now let us write their values. One second. One into 2 power 0 means it is 1. 1 into 1 it is 1. And here 2 power 1 it is 2. 2 into 1 it is 2. 0 into anything it is 0. And here 0 into anything it is 0. Let us don't take this. 2 power 3 it is 8. And 2 power 4 it is 16. And 0 into anything it is 0. Let us don't take this. Zero into anything, even this is 0. And finally 2 power 7 it is 128. So adding all this will get how much? 155. So the answer is 155 base 10 because we're converting into decimal. 155 base 10 is the answer. See, in this from decimal to binary, we have seen decimal points like 10.25. But here, let us try the decimal points. 1 second. Here, let us convert convert 1 second. 110 base 2 base 2 to base 10. We are converting this number, this binary digits to decimal. So same. First, let us take this now. 110. Let us take first this. So for 1, So let us try take for this first. 1 into, first let us take left side numbers from the decimal point. Let us take for this first. The first number is 1. So 1 into 2 power 0, the place value, plus the next is 0, right? So I'm taking 0 into 2 power 1 plus 1 into, next number is 1, so I have taken 1 into 2 power 2 plus 1 into 2 power 3. Now this part is done from left side. Let us take the number of this one, 0 and, okay. Let us keep this point and then we'll start. 0. Now we have to start from 0, this side. Okay, we have to start from 0. First it is 0, let us start with 0. 0 into power minus 1. We're not starting with 0. We have to start with decimal because it is right side of the decimal. So we have to start with minus 1. Okay. Then plus 1 into 2 power of minus 3. Let us take the value. 0 into anything, it is 0. And for this, we'll get 2 power 2, it is 4. 0 plus 4, it is 4. And here, 1 into 2 power 0 is how much? 1. And here, zero, because 0 into anything, it is 0. 1 into 2 power 4, 2 power 2, it is 4. 2 power 8, it is 2 power 3, it is 8. So adding all this, we'll get 13. Point. How much we got here? 4. So the answer is 13.4 base 10. That's our answer. We'll see the questions. Okay. Which of the following is an input device? So, which are the input device in this? Let us move to the first slide. And along with that, we can just recall everything what we have seen. See here, what are input device? Keyboard, mouse, scanner, and microphone. And output device are monitor, printer, and speaker. And your hardware, physical parts are CPU, monitor, keyboard, and mouse, and software, what is program, and operating systems are the software products. We'll answer the first question. So, which is the input device here? Keyboard, yes. Keyboard is the right answer for this. Then, how many bits are there in 1 byte? It's here itself. In 1 byte, we have 8 bits. We have 8 bits. What does CPU stand for? Central processing. Sorry. What is the full form of CPU? Central processing unit. Not control, it is central processing unit. Option C is the right answer. Binary equivalent of decimal type. You have to convert this decimal into binary. So, what is the answer for this? It is solved. When you need to convert to decimal, you have to divide the given number by 2. So 2 5s are 10, 0 reminder, 2 twos are 4, 1 reminder, 2 ones are 2, 0 reminder, then 2. We cannot divide 1 by 2, so it is 0 here. And what is the reminder? 1. Now we have to write from down. So answer is 0. Sorry, answer is 1, 0, 1, 0. We need to write from downward. So which is the option here? E. A is the right answer for this. Okay, along with this, take one more question. Who is the father of computer? Father of computer is, answer is what? Charles Babbage. He's the father of computer. Next, along with this, okay, let us see what is the full form of computer. Computer means commonly operated machine machines used in technical and educational, one second, educational research. This is the full form of computer. This is the abbreviation of computer. Commonly operated machine used in technical and educational research. This is the full form of computer. Okay, which of the following is called what is called as brain of computer? So we all know that CPU is called as brain of computer. Okay. Along with this, let us see which is the smallest unit. The questions can be like, which is the smallest unit of data in a computer? Smallest unit of data in computer is which one? I'll give the option: bit, bytes, KB, GB. So your answer will be bit. Bit is the smallest unit of data. Bit is the answer for this. Now the questions will be from the basic of computer topic. And data will be represented in binary code, that is 0 and 1. Remember this data table. Take a note of this data table. How to convert from decimal to binary and also from binary to decimal. This is also done. And data refers to raw data, raw fact like figures, symbols, images, audio, which are in raw, they are called as data. Which are processed or called as information. We have seen the type of generation. There are 5 types of generation. We are in fifth one. We are in fifth generation. Along with that, we are using fourth generation also. You have seen types of memory, and in that, how many types are there in RAM and ROM? We have seen that. What is CPU? We know that it perform arithmetic logic unit, perform calculation. Are the input and output devices, and we have seen the hardware and software of the computer. User is nothing but people who interact with the system. Yes. Yeah, now we have seen the components of computer system, and we have seen the types of memory and storage, and we have seen what is data representation and how to convert from binary to decimal and decimal to binary. We have seen that. Okay, now you all can take break of 15 minutes and you have to be back exactly at 11:45. Welcome back. Now we are going to start with the topic binary arithmetic operation. This involves performing addition, subtraction, multiplication, and division using binary numbers. Binary base number is what? 2, right? Binary base number is 2. That is only 0 and 1. This operation are fundamental in computer science and digital electronics, forming the basis for how the computer process information. Based on these, the computer process the information. Now we'll see what is binary addition, what is binary subtraction, and what is binary multiplication, binary division. Okay, what is binary number system? Binary uses only 2 digits that are 0 and 1. Each digit is called as a bit. Remember that each digit is called a bit. For binary, the base number is 2. And we all seen that to converting binary to decimal. How to convert to binary to decimal? Do you remember that? So take this number 2 into 2 power 0 first, the place value, into 1. Then 2 into 2 power 1 into 1. Power 2 into 0 into power 3 into 1. Now 2 power 0 means it is 1. 1 into 1 will get 1. Then 2 power 1 it is 2 into 1 it is 2. Then anything multiplied with 0 is 0. 2 power 3 is 8 into 1 8. So adding all this will get 11. So 1011 base 2. When you convert into decimal, it will become 11 base 10. We got the answer. Adding all this will get 11. That is what they are given here. Right? One second. First, we'll see the binary addition rule. This rule is similar to the decimal addition. But here we'll do only with the 2 digit, that is 0 and 1. This is similar to the decimal addition. Okay. See here. 0 and 0, it is 0. 0 and 0 plus 1, it is 1. 1 plus 0, it is 1. 1 plus 1, it is 10. but we'll take 0 here and the 1 will be carry. Okay, remember that 1 plus 1 equals 10. Okay, but we'll take only the 0. This one will be carry over to the next one. So 1 plus 1 will write it as 0. The 1 will be carry over to the next one. Got it? Okay. For example, we'll take a small example here. We'll add 0, 0, 1, 0. We'll add and check for this. 0 plus 0 it is 0. 1 plus 1 it is 10. We're writing only 0 here. 1 will be carried forward to the next one. So for this we're adding 1. So 1 plus 0 it is 1. 1 plus 1 it is 10 again. What you have to do? You have to write 0. 1 will be carried forward. We're not having anything here. So we'll write that 1 here. So this is your answer. 1, 0, 0, 0. This is how we are going to do the addition in binary. Subtraction. 0 minus 0, it is 0. 1 minus 0, it is 1. 1 minus 1, it is 0. But 0 minus 1, it is not possible. We cannot subtract 0 with 1, right? So what we have to do? We have to take a borrow from the next one. Okay? You have to take the borrow. We'll see the problem on this, don't worry. That. First, we'll see the rules how to do. 0 into 0, it is 0. 0 into 1, it is 0. 1 into 0, it is 0. Only 1 into 1, it is 1. This is so simple. Zero divided by 1, it is 0. We cannot divide 0 by 1. Same way. 1 divided by 1, it is 1. See, we cannot divide by 0. So it is not possible. 1 divided by 0, it is not possible. Or 0 divided by 0, it is 0. So we're taking only this two. Remember, 0 divided by 1 is 0. 1 divided by 1 is 1. These are the basics rules. Okay. Take the note of this. Binary addition. This is similar to the decimal addition. But you have to remember 1 plus 1 it is 10. You are keeping only 0 there and 1 to the carry forward to the next one. Okay. This is also a mirror decimal subtraction. Here we need to borrow, like similar to decimal one, but little trickier. This is also similar to the binary one, but involves shifting and adding partial product, just like a decimal multiplication. Then binary division, similar to the decimal division. This also follows same principle as decimal division, but with the binary digits. And it involves repeated subtraction and shifting. Now let us solve. Take the question. Okay. We'll solve as much as possible questions. Okay. One, zero, 1, 0 plus 0, 0, 1, 1. What is the rule? 0 plus 0, it is 0. 0 plus 1, it is 1. 1 plus 0, it is 1. And I'll write it here. 1 plus 1, it is 10. But we'll write 0 and 1 to the carry forward to the next one. This is what we have seen in the addition, binary addition rule. So 0 plus 1, it is 1. 1 plus 1, it is 10. But we'll write 0 here and 1 to the next one. So 0 plus 0, it is 0. 0 plus 1, it is 1. And 1 plus 0, it is 1. So for this, the answer is 1, 1, 0, 1. We'll take an example of other numbers. 1, 1, 1, 0, 1, 1 plus 1, 1, 0, 1. Okay. 1, 0, 1, 1, 1, 1, 0, 1. So 1 plus 1. First, let us check the question whether I. First, we need to check the values you have written properly about 1011, 1011, 1101, 101. Okay. Now, 1 plus 1, it is 10. So 1 plus 1, it is 1010. You have to keep the 0 here and 1 should be carried forward to the next one. So this 1 plus 0 is 1. So from this we got 1 plus the carry over 1 plus 1. Again it is 0. Carry forward to the next one. 1 will be carried forwarded. So 1 plus 1, it is 0. 1 will be carried forward to the next one. So here 1 plus 1, it is 10. 10 plus 1, it is 1, 1. So 1 here and 1 will be carried forward to the next one. But there is no any other number. So right here. Got it? C. when it is 1 plus 1, the value will be 0 and value will be 10. In that we'll keep 0 and 1 will be forwarded. Here we are having 1 plus 1 and again we have a carry forwarded value 1. So 1 plus 1 it is 1 0 10. Again plus 1 it is 11. You have to think like that. So writing 1 here and another 1 to the carry over for the next one. And there is no any other number, so you have to write that one as it is. You see, that's all. Okay, we'll take a bigger number for this. One, zero, 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 one, one, plus, sorry, one, one, zero, zero, one, one, one. So let us do the addition. What 1 plus 1 it is? I'll use a different color. 1 plus 1 it is 10, but we're writing 0 and 1 to the next one. Got it? Next, 1 plus 1, first let us add only this to 1 plus 1, it is 10. Yes, 10 plus 1 it is excuse me, 10 plus 1 it is 11. So from this 1 plus 1 we got 10. 10 plus 1 it is 11. We got 11. I'll write it separately. This 11, this digit we're writing here, and one more digit will be carry forwarded to the next one here. Just carry forwarded to the next one. Here also 1 plus 1 it is 10. We are writing 0 here and 1 is carry forward to the next one. Right? Okay, now 1 plus 1 it is 10. So writing 0 and 1 will be carry forward to the next one. So 0 plus 0 it is 0, 0 plus 1 it is 1. 1 plus 0 it is 1. 0 plus 1 it is 1. 1 plus 1 it is 10. We're writing 0 and 1 will be carry forwarded. There is no any other number. Writing that 1 as it is here. So this is how we need to calculate the, we need to follow the binary arithmetic rule. Okay, we'll solve a few more problems. Let's do this. Okay, we have seen adding two binary numbers. We'll see how to solve three binary numbers. Okay. One, 1 0 1 0 1 plus 1 0 0 1 1 0 plus 1 0 0 1 1 1. So now let us solve this. 1 plus 1, 1 plus 0 it is 1, 0 plus, sorry, 1 plus 0 it is 1, 1 plus 1 it is 10. So 0 we are writing here and 1 here. Next. 1 plus 1 it is 10, 10 plus 1 it is how much? 1. Okay, 1 plus 1 it is 10, 10 plus 1 it is 11. 1 you are writing here and 1 here. 1 plus 1 it is 1 plus 1 it is 0. 10 we are writing 1 to the next one and plus 0. Again for that we'll get 11 and 11 plus 1 again it is 0. So we're writing 0 here. Then 0 plus 0 plus 0. So it is 0. Here. This carry forward will be there, right? That will be here. Then this also will be carry forward 1 will be there here. So 1 plus 1 it is 0. Sorry, 1 plus 1 it is 10. So that we are writing here and 1 will be carry forwarded. Then 1 plus 1 it is 10, 10 plus 1 it is 11, plus 1 it is 0 and 1 will be carry forwarded. So this will be the answer for this 3 addition. So what is the thing is, we have to follow the same addition to 1 plus 1 it is, sorry, we'll start with 0. 0 plus 0 plus 0 it is 0. 0 plus 1 it is 1. 1 plus 0 it is 1. 1 plus 1 it is 10. In that we're writing only the 0 and 1 will be carry forwarded. Likewise, here also it is carry forwarded. And from here also it is carry forwarded. What is carry forwarded? 10 is carry forwarded here. So in that where 0 plus 0 plus 0 plus 0 it is 0 and 1 will be the carry forward to the next one. So 1 plus 1 it is 0 and 1 will be carry forwarded and 1 plus 1 it is 1 0 plus 1 1 1 plus 1 it is 1 0. So the final answer is 1 0 0 0 1 0. So you have to follow the same method. Now we'll move on to the, okay, we'll solve when this out. 1 0, but mainly focus on 2 addition, that's all. So 1 plus 1, it is 10. We're writing 0 here. 1 will be carry forwarded. 1 plus 1, it is 10. 10 plus 1, it is 11. 1, 1. 1 we are writing here. 1 will be carry forwarded. 1 plus 1, it is 10. So plus 0, 10. So 0 and 1 will be the carry forward. 1 plus 1, it is 10. 0 we are writing here. 1 will be carry forward. 1 plus 1, it is 10. 10 plus 1 is 11. 1 we're writing here, 1 will be carried forward. There is no other number writing both here itself. So the answer for this is 1, 1, 0, 0, 1, 0. This is the answer. Just focus on 2 addition, that is enough. Then subtraction. One minus zero, it is one. We'll recall it again. Okay, we'll start zero, zero. Okay, we'll start with zero first. 0 minus 0, it is 0. 1 minus 0, it is 1. 1 minus 1 is equal to 0. 0 minus 1 equals 1, but we need to borrow from the next one. We need to borrow 1 from the next one. Now, one, 1, 0, 1 minus 1, 0, 1. What is there here? 1 minus 1, it is 0. 0 minus 1. So what we have to do? We have to take a borrow from this. Similar to decimal, what we do in the decimal one. See here, 16, it is an example, 16 minus 8. How we do in the decimal, that I am showing here. See, we cannot subtract 6 with 8, right? So what you have to do? We have to borrow. When you borrow, this 1 become 10. So that means 10 times of that. So 16, it will become 16. So this will become 0, right? 10 minus 8, it is not 10 minus 8. It will, when this is moving to the next one, this position value will be 10 times of that. So 16 plus 10. So it is 6 plus 10, it is 16. This will be when you are taking borrow from next one, this number will become added with 10. It's 10 times of this, right? So 16 minus 8, it is 8. Same way, when you're taking 1 to here, it will become 2 because it is in base now. This value are in base. So they're in this value are in binary. So when you're taking borrow from the next one, this will become 2. This 1 will become 2 because this is in binary way. But here it is in decimal. Here it is in binary. So when you're taking a borrowing from the next digit, this 1 will become 2 and this will be 0. This will be when you're taking a borrow, this 1 will become 0 and this when you're borrowing, this will become 2. So 2 minus 1, it is 1. 0 minus 0, it is 0. 1 minus 1, it is 0. This is your answer. I'll explain it again. Listen carefully. 1, 1, 0, 1. 1, 0, 1, 1. Right? 1 minus 1 it is 0. 1 minus 1 it is 0. 0 minus 1. 0 minus, we have to borrow. So you have to borrow from the next one. When you are borrowing, this 1 will become 2. Okay, because in decimal, 16 minus 8, I have given you the example. We cannot subtract 8 with 16. So, sorry, with 6. So what we'll do, we'll take a borrow. So this number will become 16. That means this value 10 times, one value 10 times it has been. So same here, this is in binary. When you're taking here, it will become 2 times of that. So this one value is going here, so it will become 2 times of that. So 2 minus 1 it is 1. And this will be, we have taken already. So here it will be 0. 0 minus 0, it is 0. 1 minus 1, it is 0. So this is your answer. This is how we need to solve. Now we'll solve one more. 1, 1, 1, 0, 1. And 0, 1, 1, 1. Okay, this is here. This question is 1, 1, 0, 1, 1. So we need to subtract now. So we know that 1 minus 1 is 0. 0 minus 0 is also 0. So 1 minus 0 is 1. So 0 minus 1, you have to take a borrow. So 1 minus 1, it is 0. Here what we have to do, we cannot subtract 0 with 1. So we have to take a borrow. We have to borrow. So when you borrow, this will become 2. So here it is 0 now. So 2 minus 1, it is 1. Next, now here it is 0 and here it is 1. Now we cannot subtract 0 with 1. So what we have to do? Again you have to borrow. So that time this will become 2 and this will become 0. 2 minus 1, it is 1. So 0 minus 0, it is 0. And 1 minus 1, it is 0. So this is your answer. This is how you need to solve. Okay. I think you have a clear idea about this addition, binary addition and binary subtraction. Now we are moving on to the binary multiplication. Okay, along with this, we'll solve one more problem just for your understanding. One, 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 zero, one, 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 zero, zero, 1, 1, 1. We need to subtract now. So it is very simple. 1 minus 1. Okay, I'll write the rules here. 0. 1 minus 0 is 1. 0 minus 1. We need to take a borrow. Then 1 minus 1, it is 0. Here we need to take a borrow. The next one, this is B. This is not 0, this is B. Now, one minus one, it is 0. Minus 1, it is 0. Here 0 minus 1, you have to take a borrow from the next one. When you're taking borrow, this will become 2. So this will be 0. So 2 minus 1, it is 1. And 0 minus 0, it is 0. 1 minus 0, it is 1. And 1 minus 1, it is 0. I think now it is clear to everyone. Now we'll move to multiplication. Similar to the decimal multiplication. First, we have to write like normally what we do for the decimal multiplication. Just write the numbers into 1, 1, 0. Now we'll start multiplying. First, we know, first I'll write the rules over here. 0 into 0, it is 0. 0 into 1, it is 1. Sorry, 0 into 1, it is 0. 1 into 0 is also 0. When it is 1, only when it is multiplied with 1 into 1, it is 1. So we all know this, right? This is a rule we all know. So we'll follow this rule. What you have to do, you have to take this number first and you have to multiply with all other number. 1 into 0, it is 0. Then 1 into 0 into 0, it is 0. 0 into 1, 0 into 1, it is 0. Again 0 with 1, it is 0. Now we are done with this 0. Now let us take now 1. You have to multiply all the numbers with this 1. But you have to leave the space here. Like normal multiplication, what we do with the decimal number. So 1 into 1, it is 1. 1 into 0, it is 0. So 1 into 1, it is 1. Again 1 into 1, it is 1. Next. Next, what you have to leave two space. Similar, same to decimal multiplication. First, you have left one space. Here, you have to leave us two space. Now, we have to multiply with this number. 1 into 1, it is 1. 1 into 0, it is 0. 1 into 1, it is 1. Then 1 into 1, it is 1. Now, we multiplied all the numbers with this, right? Now, we need to what we normally do when you do the multiplication in the decimal number, after multiplying, we'll just add. Here also you have to follow the same method. Here also you need to add. So 0x into, so it is 0. 0 plus 1, it is what? What is the answer? Sorry. 0 plus 1, it is 1. 0 plus 0 is 0. 0 plus 1, it is 1. Again, here it is 1. 1 plus 1, it is 0. So this one will be carried forward to the next one. Up to it's clear, right? 1 plus 1, it is 10. So writing only 0 here, 1 will be carried forward to this. So yeah. So 1 plus 1, it is 10. We're writing 0, 1 will be carried forward. There is no any other number to add. So we'll write it here itself. So the answer is 1 0 0 1 1 1 0. This is your answer. Okay, we'll try with other one. One, 0, 1, and 1. We need to multiply this with 1, 1, 0. Let us start with 0 now. Just for your understanding, I'm using different colors. So first, you have to multiply this number with all the numbers. This, 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 this. So 0 into 1, it is 0, 0 into 1, 0 with anything, it is 0 itself. So 0, 0 into 0, it is 0, 0 into 1, it is 0, again 0 into 1, it is 0, right? Okay. Next, we have to multiply all the numbers with 1. Now we have to leave one space here and we have to start writing from the next page. 1 into 1, 1 into 1, 1 into 1, like this we have to follow. So 1 into 1, it is 1. 1 into 1, it is 1. To 0, it is 0. 1 into 1, it is 1. 1 into 1, it is 1. Next. In next step, we have to leave 2 space. Right? There. All the numbers. 1 into 1, it is 1. Again, 1 into 1, it is 1. 0, it is 0. 1 into 1, it is 1. 1 into 1, it is 1. So, next step is we need to add all this. Similar addition. 0 in 0. Adding all this will get 0. 0 plus 1, it is 1. 0 plus 1, it is 1. 1 plus 1, it is 10. We're writing 0 here. 1 will be carry forward to the next one. So 1 plus 1, it is again 10. We're writing 0. 1 will be carry forwarded to the next one. Same. 1 plus 1, it is 10. Writing 0 here, 1 will be carry forward to the next one. So 1 plus 1, it is 10. 10 plus 1, it is 11. 1 we are writing here. 1 will be carry forward to the next one. Then 1 plus 1 is how much? 10. Writing 0 here. And 1 will be carry forward to the next one, but there is no any other number writing that here itself. So 1 0 1 0 0 0 1 0 is your answer. This is similar to the multiplication what we do. Same similar to the multiplication. Okay, I'll give you one more. You need to solve this. 1 1 1 1 0 1 1 into 1 0 0. So how will you do this? 1 1 1 1 0 1 1 into 100. You have to multiply all the numbers. So multiplying 0 with any other number will be 0 itself. So first will be 0 0 0. So again, the next number is also 0, but we have to leave one space here. So followed by 0 again. Next we have to leave 2 space and we have to multiply with 1. So multiplying with 1, it will be same. So 1 1 0 1 1 1 1. So adding all this, the answer is for this, it is very simple. So answer will be 1. You can calculate, the answer will be 1 1 1 1 0 1 1 0 0. When there is a 0 number, just don't calculate it. Like that row entirely will be a 0 when you're multiplying with 0. When you're multiplying with 1, the row will be same what they have given. See here, when you're multiplying 0, the whole row will be 0, right? You're multiplying with 1, the next row you have to leave the space. You have to leave first blank space, and you have to first place you have to mark it as x, and then you have to continue, right? There you have to be careful. See, when you're multiplying with, we have the same value 11011 11011. So it is very simple. The multiplication in arithmetic binary operation, binary multiplication is very simple. We'll move on to binary division. First, let us see the rule what they have given in binary division. Just two rules, that's all. 0 divided by 1 is equal to 0. 1 divided by 1 is equal to 1. And it cannot be any number. Number cannot be divided by 0. What we have to do is similar to division method, what we do in the decimal number. Just like 1, 1, 1, 1, 0, 0, 0. 1, 0. We are this is a divisor, this is a dividend. So we have to divide this number with 100. So 100 ones are, let us take 100 ones are. So 100 ones are, it is 100. Let us don't call it as 100, let us take it as 100 ones. Okay, just for your understanding. So now we have to follow the division rule. What is the division rule? Zero divide by 1 is equal to 0. Then 1 divided by 1 is equal to 1. And what is the subtraction rule? Because we need to do subtraction. Similar to division, what we follow for decimal 1. 1 minus 0, it is 1. 1 minus 0, it is 1. The subtraction rule. 1 minus 0, it is 1. 0 minus 0, it is 0. 1 minus 1 is equal to 0. Same. Then 0 minus 1. Only for that we need to take a ball. Now 100. 100 into 1 is 100. Okay. So 1 minus 0, it is 1. 1 minus 0, it is 1. 1 minus 1, it is 0. So let us don't take that now. You have to take this down. Next, again, 100, 100, ones. Again, 1 minus 0, it is 1. 1 minus 0, it is 1. 1 minus 1, it is 0. Then we have to take the next one. Then again into 1. 0 minus 0, it is 0. 1 minus 0, it is 1. Right? So 1 minus 1, it is 0. Next, we have to take this. Again, it is 100 into 1. So you're writing again here 100. 0 minus 0, it is 0. 0 minus 0, it is 0. 0 minus 0. 1 minus 1, it is 0. Don't write that 0. It's just cancel that. Then again, we have to take this. So when you take this here, so 100 is not ones are now 100 into 0, because we're doing 100 into 0 because we need to cancel this 0. So 100 into 0, it is 0, 0, 0. Now all this are got cancelled. So the answer of this is 1110. This is the value. This is the value. Got it? Now we'll solve the next one. You have to divide this 1000 with 10. So 10 ones now. 10. You have to subtract 0 minus 0, it is 0. 1 minus 1, it is 0. Then take this 0. So next we need 1 second. Don't write 0 here. It is just cancelled, so leave that space. So 0, take down. So we need then we have to cancel this. So to do that, so we have to multiply 1 0 with 0. Then only we'll get 0 0. 0 minus 0, it is 0. This also will get cancelled. So this number will have to be again. Cancel this number should be 0. So 10 into 1 0 into 0, it is again 0 0. Now all got cancelled. Nothing is remaining now. The answer is 100. This is the answer. Decimal of 1011 plus 0101. First, we need to convert this to the decimal. Now they are in a binary form. This should be converted to the decimal. First, let us find the value of this. One into 2 power 0. You have to start with 0. Place value. Then 1 into 2 power 1 plus 0 into power 2 plus 1 into 2 power 3. Once again. 0, 1, 2, 3. And the binary numbers are correct. We have to cross verify. 1, 0, 1. Okay, now let us do the calculation. 2 power 0 is 1. So 1 into 1. From this we got 1. 2 power 1 is 2. Into 1, it is 2. Anything that is 0. So 2 power 3, it is 8. 8 into 1, it is 8. Adding all this will get 11. This is the value for 1011. Now we have to find it for 10101. So 1 into 1 into 2 power 0 plus 2, sorry, 0 into 2 power 1 plus 1 into power 2 plus 0 into 2 power 3. Now multiply anything 0 for this 2. 1 into 2 power 2, it is 2 power 2 is 4. 4 into 1, 4 plus 0 into anything, it is 0. Then 2 power 0, it is 1. 1 into 1, it is 1. So from this we got 5. Adding both 11 plus 5, it is 16. So 16 is your answer. Option C. 16 is the answer for this. Two more questions related to this. So one more problem for division. 1 1 0 0 divided by 100 will take. Here we are taken 4 1 3 4 ones. Here we take 3 1. So divided, this is the divisor, 100 is the divisor, 11100 is the divided. So let us take one more 0 here. Okay, add one more 0 over here. Now let us divide this. So 100 into 1 0. So it is same 1 0 0. Divide this. We have to subtract same as what we do for the decimal number. 1 minus 0, it is 1. 1 minus 0, it is 1. 1 minus 1, it is 0. Don't take that number, just leave it as it is. And 0 will carry to here. So again 100, 100, 1 0, it is 1, 0, 0. It is 0, 1 0, it is 1. And 1 minus 1, 1 minus 1, it is 0, just leave as it is. This is carry forward. 100 ones. So next is 0 and this is 0. So 1 minus 1, it is 0, don't take that. Next, this will be carry forwarded. You can take this here and you can multiply this with 100 with 0, or you can directly take this 0 over here. Answer will be same. For this, the answer is 1110. Okay. We have found the answer for this. Along with this, we'll have a binary arithmetic operation. 1 0. Just by the sign, you'll come to know whether it is a addition or subtraction or multiplication or division. Find the answer for this. 0 1 0 1 minus 1 0 0 1, then 1 0 1 into 1 1, then 1 1 0 0 0 into 1 0 0. So find the answer for all this. So if they ask you the question for decimal, this is how we need to find. If not, if they give you like this, you have to do the arithmetic operation. So what is the answer for this? 1 1 0 1 1 0 1 1. So what we have to do? We have to add 1 plus 1, it is 10. We are writing 0 here, 1 will be carried forward. 1 plus 1, again it is 10. We are writing 0 here, 1 will be carried forward. 1 plus 1, again it is 10. We will write 0 here, 1 will be carried forwarded. 1 plus 1, it is 10. 10 plus 1, it is 11. We are writing 1 here, 1 will be carried forward, but there is no any other number, so you'll write 1 here itself. So the answer is 1 1 triple 0. For this, 1 1 0 0 0. Remember the rules, what I've taught you. You have to write that in a corner of the sheet and you have to practice. For this is the answer. 1 plus 1, it is 10. We're writing 0 here. Okay. We're writing 1 plus 1, it is 10. We're writing 0 here and 1 will be carried forwarded. Okay. Remember 1 plus 1, it is 10. It is not 0, it is 10. We're writing only 0 here, 1 will be carried forwarded. Okay. In case of 1 plus 1 plus 1. In case of 1 plus 1 plus 1. 1 plus 1, it is 10. 10 plus 1, it is 11. So writing 1 here and 1, another 1 will be carried forward to the next one. 1 0 1 0 1 minus 1 0 0. Sorry. In this we have only 5 digits. In this we have 4 digits. 1 0 0 1. One plus you have to subtract here. 1 minus 1, 1 minus 1, it is 0. 0 minus 0, it is 0. 1 minus 0, it is 0 minus 1. It is not possible. You have to take a borrow to borrow from the next one. So when you get borrow, this 0 will become 2 and this 1 will become 0. Why it is becoming 2? Because it is a binary number. When you're doing the decimal, it is doubling. So here it's a binary number. So here when you're borrowing from next one, it will become 2. 2 minus 1, it is 1. And here there is no number, so as 1100. For this, the answer is 1100. If you want to cross verify this, you have one more method. You can convert this to the decimal number, even this to the decimal number, and then you can check. Even this also you have to convert to the decimal number. You're converting this to decimal number, it is 21. And when you convert this to decimal number, it is 9. See here, this 2 power 0. So 1 into 1, it is 1. And here, 2 power 0, 1, 2. Here it is 4, 1. And here, 2 power 0, 1, 2, 3, 4. 2 power 4, it is 16. So 16 plus 4, it is 20. 20 plus 1, 21. When you're converting this binary to decimal, you will get 21. Best. Same way, here it is 1 and 2 power 0, 2 power 1, 2 power 2, 2 power 3. So 2 power 3 is 8. So 8 into 1, 1. 8 plus 1, it is 9. You can directly do. See, for this, the base, the decimal value is 9. So 21 minus 9, it is 12. So this decimal value should be 12. Let us check. This 0, 0, 2 power 0, 2 power 1, 2 power 2. 2 power 2 is 4. This decimal value should be 12. 2 power 2 is 4 and 2 power 3 is 8. So 8 plus 4 is 12. We got 12. This like this you can cross verify if you have time. Next we'll solve it for 101 into 1. Just cross multiply this when you're multiplying with 1. You have to multiply all the numbers with this. Similar to the decimal multiplication 101. And you have to leave a space. So, then adding 1, 1, 0 plus 1, 1. For this, the answer is triple times 1. Just cross verify this. 101 into 11. So we're writing the same 1, 0, 1 into 1, 0, 1. So answer is 4 ones. Now we'll do it for This is a multiplication. This is a division one. Let us try here itself. 1, 1, 0, 0, 0. 0. So ones are 1, 0, 0. So it is 0 minus 0, it is 0, 1 minus 0, it is 1, 1 minus 1, it is 0. Then you have to bring it this down. Again, ones up. 1, 0, 0. All will get cancelled. So 0, 0. Next, you have to bring this down. You can directly write 0, or you can do the further step again. 0 and 0, 0, 0, 0, and everything will get cancelled. 0. So this is your answer. And I will give you a problem which is mixed. Give a problem which is mixed. It's mixed of addition and the multiplication. 1, 0, 1, 0 plus. You won't get this type of problem, but still, to make you understand better, I'm giving you this one. This is a mixed operation of addition and multiplication. So I've given you the small one. Okay, we'll solve this here itself. One, 0, 1, 0, 1, 0, 0, 1. We need to add all this. 0 plus 1, it is 1. 1 plus 0, it is 1. 0 plus 0, it is 0. 1 plus 1, it is 0 and 1. Right? Instead of 10, it is very simple. When you multiply with 10, 1, 0, it was added with 0. That's all. The final answer will be 1, 0, 0, 1, 1, 0. Instead of 10, let us take it as 1, 0, 1. Now the addition of this binary number is 1, 0, 0, 1, 1. Now we need to multiply this with 1, 0, 1. Okay. When you multiply with 1 with all the numbers, it will be same. 1, 1, 0, 0, 1. Then you have to leave one space and multiply with 0. When you are multiplying with 0, all the numbers will become, all the digit will become 0, 0, 0. Again, you have to leave two space and you have to multiply with 1. When you multiply, it will be the same. Now you have to add all this. 1 plus x, it is 1. 1 plus 0, it is 1. 1 plus 0, 0, 0, it is 1. 1 plus 0, 0, it is 1. 1 plus 0, 0, 0, it is 1. 0 plus 0, it is 0. And it is 1. The final answer is 1, 0, 1, 1, 1, 1, 1. This is your answer. This is your answer. 1, 0, 1, 1 into 1, 0, 1 is just cross verify again. Yeah, it's right. 1, 0, 1, 1, 1, 1. 1, 0, 1, 1, 1, 1, 1. If you want to cross verify, again you can convert this to the decimal one. You have to convert this to decimal, this to the decimal, again this to decimal and add. And again convert this to the decimal and multiply. That multiplied decimal number should be same what we have got here. Okay, we'll find the final answer, the decimal value of this. 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6. And when you're multiplying with 0, this will be 0. Don't calculate this. 2 power 0 is 1, 1 into 1, it is 1. 2 power 1 is 2, 2 into 1, it is 2. 2 power 2 is 4, 2 power 3 is 8, 2 power 4 is 16, 2 power 5 into 0, it is 0, 2 power 6 so is how much? 64. Add all this. 64 plus 16 plus 8 plus 4 plus 2 plus 1 is 95. So the final answer when you convert to decimal, you will get 95 base 10. So if you want to cross verify, just do one thing. Just calculate this decimal value and calculate this decimal value and this decimal value and substitute and do the simplification. You'll get the answer. We have completed with the arithmetic operation. We have seen the addition method, multiplication method, division method, and subtraction method, and we have solved multiple problems on each concept. So you have seen the rules of all the arithmetic operation. Now you all can take a break and be back at sharp 2 o'clock.